In this video, I will introduce indeterminate forms for limits. I want to explain what it means and what it doesn't mean to have an indeterminate form. In the later videos, linked in the description, I will explain how to resolve them, how to actually compute limits. But for now, I only want to explain what an indeterminate form is. As motivation, consider this limit. The function is a quotient. The numerator and denominator are both nice continuous functions. So I may be tempted to evaluate. But if I simply evaluate, I get 0 divided by 0. That is not the answer. That is not a number. That makes no sense. Instead, we have an indeterminate form. This indeterminate form appears when I try to compute certain types of quotients. Let's say I want to compute the limit of f divided by g. And I know something about f and g. If I know the limit of f is 2 and the limit of g is 3, what can I conclude about the limit of the quotient? That is easy. The limit of the quotient is 2/3. That is a simple use of limit laws. Another example. If I know the limit of f is 1 and the limit of g is infinity, what can I conclude about the limit of the quotient? In this case, the limit of the quotient is 0. We can prove this from the definition of limit if necessary. However, if I know the limit of f is 0 and the limit of g is also 0, what can I conclude about the limit of the quotient? In this case, I cannot draw any conclusions about the limit of the quotient. Just based on the information I have, I do not know what the limit will be. The way to prove this is with examples. I can construct various examples that are all of this type, 0 divided by 0, but where the final answer, the limit of the quotient, is different in each case. Let's do that. All of these limits will be as x approaches 0. The limit of 2x over x is 2. Just simplify the function before computing the limit. The limit of x squared over x is 0. Same argument. Simplify the function before computing the limit. And the limit of x over x cubed is infinity. That's it. That proves my claim. In these three examples, the limit of the numerator is always 0, the limit of the denominator is always 0, but the limit of the quotient is different in each case. We say that 0 divided by 0 is a limit indeterminate form. And what it means is what I have at the top, nothing more, nothing less. Indeterminate form means that whenever we encounter this type of limit, 0 over 0, just from knowing that it is 0 over 0, I cannot draw any conclusions. I have some important remarks to make. First, we are talking about limits. We are never actually dividing 0 by 0. For any value of x, I will have something close to 0 divided by something close to 0. Second, indeterminate form does not mean that the limit of the quotient is undefined or that it doesn't exist. Its particular case may be different. Some may exist and some may not. It only means that we do not know what the answer is yet and we have to do more work. And third, indeterminate forms normally arise because there is a tension between two pieces of the function. In this case, the numerator thinks 0 divided by anything is 0, so the numerator wants to make the quotient have limit 0. And the denominator thinks anything divided by 0 is plus or minus infinity, so the denominator wants to make the quotient have limit plus or minus infinity. And this becomes a competition between f and g to see which one approaches 0 faster, so which one pulls faster. All other indeterminate forms can also be understood as this kind of tension between two pieces of the function. The most common indeterminate forms are 0 over 0, plus or minus infinity over plus or minus infinity, 0 times infinity, infinity minus infinity, and the exponential types, 0 to the 0, infinity to the 0, and 1 to the plus or minus infinity. And a very useful tool to solve some indeterminate forms is L'Hopital's rule. In the next sequence of videos, I will explain what L'Hopital's rules say, present examples on how to use it, explain how L'Hopital's rule may fail if misused, and go over the different types of indeterminate forms to learn tricks to handle each one. But before I do that, I want to comment on one more type of limit, 1 divided by 0. Why didn't I include it in the list? If the limit of the numerator is 1 and the limit of the denominator is 0, what can we conclude about the limit of the quotient? We do not normally consider this an indeterminate form because we can conclude something, but we have to be careful. In this situation, I may be tempted to say that the limit of the quotient is going to be infinity. But I can only conclude that the limit of the absolute value of the quotient is going to be infinity, because the denominator may be positive or negative. If I know that, in addition, near the point, the denominator stays positive, then I conclude the limit of the quotient is infinity. But if I know that, in addition, near the point, the denominator stays negative, then I conclude the limit of the quotient is minus infinity. For example, let's say I want to compute the limit as x approaches 3 on the right of 1 over x minus 3 times 2 minus x. This is 1 divided by 0. Let's study the sign of the denominator. As x approaches 3 on the right, x is greater than 3, x minus 3 is positive, and 2 minus x is negative. So the full denominator is negative, and the limit is minus infinity. So we have to be careful, but we can say something, and that is why I did not include 1 over 0 on the list of indeterminate forms.